another session of MAmiTEO Teaches Math. Our topic for today is solving optimization problems. This is actually the application of extreme value theorem. Let's do it. Here are some steps in solving optimization problems. First, read and understand, of course, the problem. 2. Draw a diagram if applicable. 3. Write down formulas and given information. 4. Write a function for what is to be optimized. 5. Set the derivative of the function equal to 0 and solve. Example 1. A rectangular box is to be made from a piece of cardboard, 24 cm long and 9 cm wide. By cutting out identical squares from the four corners and turning up the sides, find the volume of the largest rectangular box that can be formed. Okay, so we already, of course, read and understood it. This one is the diagram. We are looking for the volume of the largest rectangular box that can be formed from this rectangular cardboard, 24 cm long and 9 cm wide. So this one is 9 cm and this one is 24 cm. This is number 1. So we have here square in every corner. I will be naming it as X, of course. Okay. So next is, of course, write down the formula. The formula in finding the volume of a rectangular box is length times width times height. So let us identify the length through this, the width, and of course the height. And we can now conclude that this one is V of X. Why? We can be writing the length, of course, in terms of X here. Same with the width and the height. So the length here will be 24 minus 2X. The width here will be 9 minus 2X. And the height, of course, will be X. So V of X is equal now to, let us multiply the 3. So I will be multiplying this 2 first. This is 9x minus 2x squared. Okay. So V of X is equal to, this one is 36, carry 3, 216x. This one is 48x squared. This one is negative 18x squared. And this one is positive 4x cubed. So we have V of X is equal now to 216x minus, let's add, we have here 66x squared plus 4x cubed. Okay. So arranging it, this one is 4x cubed minus 66x squared plus 216x. So let us now get the first derivative of this. We have V prime of X is equal to 12x squared minus, the derivative of this is 132x, and the derivative of this is 216. Okay. So now how can we simplify this? Of course, we equate this one to 0. So we have 12x squared minus 132x plus 216. And we can divide everything by 12. So this one is 0. This is x squared. This one is 11x. And this one is what? This one is 216 divided by 12. We have 1, 12, we have 96, so 8. So this one is 18. Okay. So now, we can factor it as x minus 9 and x minus 2. Equating each factor to 0, we have x is equal to 9 and of course x is equal to 8. So these are the critical points, 2, 9. So let us evaluate v of 2. We have 4, 2 cubed minus 66, 2 squared plus 216 times 2. So v of 2 is equal to 4 times 8 minus 66 times 4 plus this one is 432. So v of 2 is equal to 32 minus this one is 24, carry 2, 24, 26 plus 432. So v of 2 is equal to, this one is 464 minus 264. V of 2 is equal to 200. Okay. What about the other one? V of 9. V of 9 is equal to 4 times 9 cubed minus 66 times 9 squared plus 216 times 9. So V of 9 is equal to 4 times, this is 729, 66 times 81, and this one is 216 times 9 is equivalent to 1944. Okay. Simplifying this, V of 9 will be equal to negative 486. Okay. So we have this point, 9, negative 486. And we have this one, 200. So which has the higher volume. Of course, this one is negative. So this one is not included. So therefore, the volume of the largest rectangular box that can be formed out of this cardboard, 24 cm long and 9 cm wide, is of course 200. Number 2. A right circular cylinder is inscribed in a sphere of radius 20 cm. What must be the dimensions of the cylinder if it is to be of maximum volume? So we are asked here to find the h, the height of the cylinder, and the radius of the cylinder. So let us illustrate it first. Suppose this one is the sphere and its radius is 20 cm. We have a cylinder here inscribed. Of course, the height is denoted by h, and we can say that this one is h over 2 and this one is the radius of the cylinder. Let us name it as r. Now we know that the volume of a cylinder is equivalent to pi r squared h. This one is the formula. How are we going to find the r? We will be finding the r since we already have the h here, meaning we will be writing r in terms of h. So how do we do that? So this one is a right triangle. I can use the Pythagorean theorem here. Longest side is equal to h over 2 squared plus r squared. So we have 400 equals h squared over 4 plus r squared. So this is now 400 minus h squared over 4 is equal to r squared. So that is our r. I am now ready to substitute it here, and we can name now our domain as dh. Okay, because we will be writing r in terms of h. So this is v of h equals pi times 400 minus h squared over 4 times dh. So v of h is equal to 400 pi h minus pi over 4 h cubed. Remember that our aim is to solve for the r and of course the h. Let us get now the first derivative of this, v prime of x. So we have derivative of 400 pi h over dx minus the derivative of pi over 4 h cubed. over dx. So this is v prime of h is equal to, this one is 400 pi minus, this one is pi over 4 times 3h squared. Derivative of this is, of course, 3h squared. So we have here 400 pi minus, this one is 3 pi over 4 h squared. And then we equate this one to 0. So we have now 3 pi over 4 h squared is equal to 400 pi. Okay, so we have 3 pi h squared is equal to 1,600 pi. Dividing both by 3 pi. So our h squared is, of course, equal to 1,600 over 3. Getting square root, our h is equal to 40 over square root of 3. Or, rationalizing it, h is equal to 40 square root of 3 over 3. So that is our height. So our height here is 40 square root of 3 over 3. Now, let us find the r. So we'll be using that one. We have r squared is equal to 400 minus h squared over 4. So I will not be using this one. Instead, I will be using 1,600 over 3. So we have r squared is equal to 400 minus, this one is 1,600 over 3 over 4. I use this one, it is because our h here is, of course, in square. So this is now r squared is equal to 400 minus 1,600 over 3 multiplied by the reciprocal 1/4. So r squared is equal to 400 minus, this one is 400 over 3. So this is now r squared equals, you cross multiply, this is 1,200 minus 400 over 3. So r squared is equal to 800 over 3. Getting the square root, of course. So our r here is equivalent to 400 times 2. I'll just simplify it. Over square root of 3. So r equals, square root of 400 is 20. Square root of 3 over, sorry, this one is square root of 2 over square root of 3. So rationalizing it, we have square root of 3, square root of 3. So r now is equal to 20 square root of 6 over 3. So this one is our r. This is, of course, in cm. And this one is our h. 40 square root of 3 over 3.